Think of the most famous science fiction world in cinema history. You picture towering mountains floating in midair, dense jungles glowing with neon bioluminescence under the cover of night, and giant blue-skinned beings roaming a vibrant ecosystem. The creator of this moon used specific astronomical constraints to build it, a set of physical rules that overlap with planetary data arriving from our own telescopes. 10-foot aliens and levitating rocks are often dismissed as fantasy, but astrophysics is starting to verify the conditions required to make these concepts physically possible. In April 2025, the James Webb Space Telescope locked onto a planet called K2-18b, 124 light-years away, and detected something previously found only on Earth. That data revealed traces of dimethyl sulfide, a gas that, in our world, is produced by microscopic plankton. It is a biological signature that suggests life might be closer than we assumed. Since we are already finding these biological markers on distant worlds, we can now put that famous cinematic world through a stress test to see if its most impossible features are actually permitted by the laws of physics. Pandora orbits a gas giant in Alpha Centauri, a real star system just 4.37 light-years away. It is our closest neighbor, and astronomers have already confirmed that planets here occupy the habitable zone, the precise distance from a star where liquid water can exist. On a moon with 80, when a superconductor expels magnetic fields, it is repelled by external forces. If a moon's superconducting minerals interact with a gas giant's intense magnetic field, the repulsion counteracts gravity, permanently levitating massive rock formations. The magic of floating mountains is simply the application of theoretical astrophysics at a planetary scale. The glowing ecosystems of that world also follow a logical path. On a moon orbiting a gas giant, nights are rarely pitch black. They are filled with long, indigo twilights. Plants and animals would evolve to emit light to communicate and navigate in this perpetual dusk. This isn't a theory. We see it in our own deep-sea environments and forest floors, where organisms use chemical reactions to create light in the dark. The most advanced technology in the story involves moving a human mind into a synthetic biological body. It seems like the peak of science fiction. Yet, researchers at Harvard and Stanford are currently mapping the human connectome. They are building a digital map of the billions of neural connections that make up an individual's identity. We are already seeing the first steps. Projects like Elon Musk's Neuralink have successfully translated brain activity into code, allowing humans to control digital devices through direct neural links. From the physics of levitation to the mechanics of the mind, the foundations of this world are being researched in laboratories today. While we use the James Webb Telescope to look for life elsewhere, that cinematic story actually tracks the industrial footprint of the people trying to reach it. The destruction of that alien biosphere is a direct mirror of our own. It shows an industrialized society consuming a planet to fuel its expansion. Satellite data shows that 35% of our world's disappearing forests have been lost in the last 50 years, cleared for the same industrial needs portrayed in the film. We strip away the Earth's surface for materials like lithium and cobalt to power our modern lives, leaving behind toxic evaporation ponds that permanently alter the landscape. Even the glowing oceans we admire have a dark counterpart. Many bioluminescent events in our waters are now stress responses, marine life reacting to the chemical pollutants we dump into the sea. And while we watch fictional whales being protected from invaders, our own commercial fleets continue to harvest intelligent sea life on a massive scale for global profit. Earth is the real Pandora, but we are currently occupying the role of the invading force. If we continue to consume our resources without change, we won't be using technology to explore new worlds. We'll be using it as a desperate attempt to survive our own.